Hello, the Math Dog here. In this video I'm going to look at a linear programming problem using the Desmos Graphing Calculator, and we're going to be maximizing profit growing and selling plants. So Desmos is an online calculator that is pretty amazing. Has great functionality and allows you to get good visuals of functions and so forth. So let's get started. So a nursery sells two products, rose bushes and maple trees. It wants to figure out how many maple trees and rose bushes to grow and sell to maximize its profit on the two items. So here is some information about the maple trees and the bushes and what the nursery has available. So square footage needed per plant. The maple tree needs 7 square feet, the rose bush 4 square feet per plant. Cubic feet of soil needed per plant is 14 cubic feet for the maple tree, 2 for the rose bush, 2 cubic feet for the rose bush. And the cost per plant is $14 to grow a maple plant, $5 to grow a rose bush. So now the nursery has the following things available. These are called constraints. Because we have limited resources. So it needs 168 square feet of planting. So the nursery has 168 square feet of planting area available. Has 210 cubic feet of soil available. The nursery has a budget of $252 for these two plants. The nursery then plans to sell the maple plant trees at $28 each and the rose bushes at $8 each. So we're going to use X and Y here as our unknowns. So, or as our variables. Let X equal the number of maple trees grown and sold. Let Y equal the number of rose bushes grown and sold. So we're going to write out now our constraint inequalities. There's going to be 5 of them. So the first one is we cannot have a negative number of maple trees and rose bushes or rose bushes. So we can state X is greater than 0 and Y has to be greater than or equal to 0. Okay, then we have our planting area constraint 168. So this is X, maple trees are X, rose bushes are Y. So we know that 7X, this is going to be 7X plus 4Y has to be less than or equal to 168. Okay, now for the cubic feet of soil, we have 210 cubic feet. We need 14 here, 2 here, so this is going to be 14 times the number of maple trees plus 2 times the number of rose bushes. So that's going to be 14X plus 2Y less than or equal to 210. And finally, we have a cost constraint. We only have $252 available, $14 per maple tree, $5 per rose bush. So we can write 14X plus 5Y must be less than or equal to 252. So I'm going to copy this because I'm going to need this in a few minutes. So copy these constraints. I'm going to send it to the clipboard. And we'll get to that in just a second. So now I'm going to write a profit function. I'm going to call it P for profit. And it's a function actually of 2 variables. So we could write as P of XY equals. So we're selling the maple trees for 28 each and the rose bushes for 8 each. But you got to remember, profit is revenue minus cost. So it's costing $14 per maple tree. So 28 minus 14. The profit is $14 per maple tree. And then rose bush is $8 you're selling at, but it's costing you 5, so that's going to be 8 minus 5, which is 3. So the profit function P of XY is going to be 14X plus 3Y. Alright, so now we have all the information we need to answer the question. We're going to graph it now using Desmos. So first of all, I'm going to paste this information here because I can't remember it. So I'm now going to open the calculator. Okay, so I'm going to put in my first two constraints. I really don't need to put in these, but I'm going to. So x greater than or equal to 0, y greater than or equal to 0, and then we've got, and I had to write these on a piece of paper because I just can't remember these. So I have 7x plus 4y less than or equal to 168. 7x plus 4y less than or equal to 168. Okay, so we're going to get these entered, then we'll change our grid, the coordinates on our grid, so we can see what we need to see. Then I have 14x plus 2y, I'm sorry, less than or equal to 210. And then finally I have 14x plus 5y is less than or equal to 252. Now the beauty of Desmos is I can actually enter these equations, like these inequalities, as is. I don't have to solve, say, for y, so that saves us a lot of work. So now let's, what I'm going to do is I'm going to, first of all, zoom out a bit. Okay, and we're zoomed out too much. Let's just manually change our grid. So we're going to go I'm going to go 0 to 80 here for x. If I can't see what I need, I'll change it. So I'm going to go 0 to 80, and then for y, I'm going to go 0 to 120. If I can get it in there. Okay, let's try that again. Zero to 120. Alright, so now this is what I want to see. Alright, so this is what we want to see, but I'm going to move this a little bit to help, I think, make it a little easier to see what we're doing. So the area we're going to look at actually is what I'm outlining here. So we're going to go here to here to here. Now why do I do that? I go with the lowest line segment at as I go left to right. So first of all, I'm going to click on this point here. That's 0.42. Okay, then I'm going to go here, click on this. It's because this is too high. Now there's nothing below this, so that's why I click on that. That's going to be 8.28. Now I keep going. This is the lowest point. There's nothing below it here. So I go there, then here. Now what I'm going to do is these are the values I'm going to plug into the profit function, and the one that gives me the greatest value will be our final answer. So I'm going to copy this graph now. And I'm going to go back to the worksheet. And actually I'm going to take it to the next page. So I'm going to copy this, cut this, go to my next page. There's my profit function. Okay, so let's go up, extend the page if we need to. So now we're going to plug in these values to this function and evaluate it. So P, let's use gold, that works pretty well. So P, I don't know if gold works so well. Let's try more contrast. I'm going to use reds, more contrasting, more contrast. So P of, then I'm going to use 0.42 for starters. That's going to be 14 times 0 plus 3 times 42. Well, 3 times 42 is 126, so that's $126 there. So then I'm going to go, so I've done this one, now I'm going to do 828. P of 828 is 14 times 8 plus 3 times 28. Okay, 14 times 8 is 112. That's going to be 112 plus 28 times 3. That's 84. If you add those up, you get $196. So now we've done that. Now we're going to do 1314. P of 1314 is 14 times 13 plus 3 times 14. And that's going to equal 14 times 13. 12 carry 1, that's 4. 0. 4 times 1 is 4. 1 times 1 is 1. That's 182. That's 182 plus 14 times 3 is 42. So that's going to give us 200 and, well, I think it's a 226. I mean 4. That's $224. And then finally we have to check P of 18, 0. That's going to be 14 times 18 plus 7 times 0. Well, 14 times 18 that's 152. So our max profit is achieved at 1314. So let's write a little summary. The profit is maximized when 13 maple trees and 14 rose bushes are grown and sold. So this concludes the work on this particular problem. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.